So thank you very much for coming. We're very excited to present this talk. Wilson is part of our CS and data science faculty. I'm going to introduce him right away. This talk is going to be a 45-minute talk, followed by a 15-minute session of questions and answers. Participants in the room, attendees, have priority on the questions. I will be fielding the questions on the chat via Zoom. So if you have questions, those who are attending online, we have 36 attendees online. Please feel free to add questions as Wilson talks, and I'll try and represent as best the questions that you submit. Okay, so let me try and have a fun introduction for you. So this is what I get when I go online on the NYU Shanghai portal and I ask for Wilson's page. And as you can see, we learn loads of stuff like Wilson is a professor of practice in computer science here at NYU Shanghai. He was a principal natural language processing scientist and manager at WeChat AI. He worked on Xiaowei, a virtual personal assistant. From 2015 to 2017, he was a senior scientist at Microsoft and Suzhou. He's got loads of experience working with international institutions. So as you can see, he knows what he's talking about. You have a selection of publications, and you can see that Wilson has a PhD from CMU. All right, so this is my short introduction. Let's ask ChatGPT to help us write a short introduction. So I'm going to start a new chat. I'm going to copy the prepared questions I had, and here we go. I've invited Yik-Cheung Wilson Tam, professor at NYU Shanghai, to talk about NLP and chatbots. It's a 1-hour talk aimed at an audience of non-experts. Can you write his short bio and the 3-sentence introduction for the talk? There you go. Here's a short bio. Wilson Tam is an assistant professor, where he leads the NLP and AI lab. Strange, I don't know this lab and I work here. His research focuses on natural language processing. This is true. Machine learning and their applications, chatbots, this is all fine. So here's your introduction, Wilson. In today's talk, Professor Yik-Cheung Wilson Tam will introduce us to the fascinating world of natural language processing and chatbots. We'll learn about how machines understand and introduce human language, generate human language, the challenges that come with building effective chatbots, and the applications of NLP in various fields. Whether you're new to the topic or already familiar with NLP and chatbots, you'll come away with a deeper understanding of this rapidly evolving field. So you'll notice that we don't have much information beyond the fact that apparently Wilson is now an assistant professor. I'm sorry for the demotion, Wilson. Let's check another question. So it seems like you didn't get it from CMU at all. You got it from HKUST. You've been hiding stuff, Wilson.
I do graduate from Hong Kong UST, but not getting the PhD there. Yeah.
Okay.
It's the problem of the ChatGPT.
Yeah, let's go just one, and then I'll hand it over to you. But I'd like to get a couple of papers that you authored. So here are a few. And can you tell us if you actually authored any of these papers?
None of them.
Okay. So I thought that this would be a good starting point, but I'm going to hand over to you, Wilson. Thank you very much for coming to talk, and the floor is yours.
Yeah, thanks, Olivier, for your very interesting, inspiring introduction. So let me share my PowerPoint to you guys. So here is the outline of my talk today. So first, I would like to give an introduction about ChatGPT, and then followed by explaining how ChatGPT can absorb world knowledge and how the ChatGPT follows human instructions. And then I'll end the talk with a summary and a discussion. So as you saw from Olivier's demo, so that was the interface from OpenAI, but in fact, you can also try the ChatGPT on Microsoft Bing, the Bing search engine. So actually, the title of the talk today, actually, I also consulted ChatGPT to help me. Like the title, I chose that I asked ChatGPT to generate a few of them, and then I chose it, the best one, and I'll modify it a little bit. And I can also like type my prompt here, that is explain what is ChatGPT. As you can see that it basically explains what is ChatGPT and also what is a large language model to a 6-year-old kid. So if you haven't tried this on a new Bing, you can certainly try it on a new Bing. Yeah. So what is ChatGPT? So ChatGPT actually stands for chat plus GPT. So GPT actually stands for generative pretraining. So actually it's like a machine that can read tons of data. So for example, on the left-hand side, we can get a lot of textual data from the web, such as Wikipedia, newswire data, and also some other web data. Or even like books, fictions, and so on, textbooks, and so on. Then this data will be formed as a form of natural languages, which is like a sequence of word tokens. Then these tokens will be fed into the procedure called generative pretraining. So we call it the GPT. Then what's the output? The output here will be basically just we call it the GPT-3 model. Actually, this model was trained and invented by OpenAI. It's a startup company, and the GPT has different versions. So it starts from GPT, which is the first version in about 2018, and then followed by GPT-2, which was trained on more data and more parameters of the model, and now GPT-3 is like trained on tons of data, and also with more model parameters. But that was not equal to ChatGPT. It's still just the pre-version of the ChatGPT. It's like a baby, a kid which are forced to learn to read a lot of text. But this kid cannot answer questions so far, may not be very good at answering questions or interpreting instructions from human. So therefore, it would need to go through another process called fine-tuning. So we just want to take the GPT-3 model, and then we try to fine-tune the model so that it will follow the human instructions better. So this will become the ChatGPT, which is a conversational bot, which can also like handle like conversations like humans. So maybe that's a very a first question is how many parameters is in the ChatGPT? There are like 4 options. A is 1 million, B is 1 billion, C is 10 billion, and D is 175 billions. What do you guys think? So indeed, so it's a large model. Actually, the number of parameters in ChatGPT is actually option D, 175 billion. So remind you guys that 1 billion byte is roughly about 1 gigabyte. So if you have like ChatGPT, which has 175 billion parameters, and each parameter will have like 4 bytes for storage or representation, then we need 700 gigabyte, roughly 700 gigabyte for storing the ChatGPT model, which can be stored in an iPhone. But of course, it cannot be run on an iPhone because it's tons of parameters for the inference. So ChatGPT, it was basically increased the model in size. So as you can see on the x-axis, there's some historical, we call it the blessings of scale. So x-axis is basically the year, which is from the 1950s and up to the current, the 2022. And we see there are different kinds of models. AI models are trained with data. For example, we have a BERT model trained by Google, and then we have the GPT-2 model trained by OpenAI, but the model size is smaller. And then we have GPT-3 model trained on 2020. The model size is much larger. And actually, the models will keep on going, as you can see the trend here. So it's keep on going, increasing the number of the size of the model parameters to have the AI bot to have more intelligent. So not just an increase in the number of parameters, we also need to, the model needs to absorb a large amount of world knowledge. So as you can see in this slide here, so if you are 13 years old human, then probably you will read about less than 100 million word tokens during these 13 years. But then these AI models, like BERT models in 2018, Roberta 2019, and then the OpenAI GPT-3 model was trained on 200 billion word tokens. And now this is 2022 or 2023, actually, ChatGPT was trained on even more data, 1.4 trillion tokens, which is quite a lot of amount of data. So essentially, ChatGPT absorbs a huge amount of world knowledge from the web and also from high quality textbooks and so on. So increase in the model size and also increase in the data would require the increase in computation. So actually, how can these companies train the ChatGPT model? So ChatGPT model is actually a deep model which requires this so-called the graphical processing unit. We call it the GPU, and the training cost is about spending 10,000 GPU cards. So probably if you like play computer games, your laptop may be equipped with one GPU card, but like a consumer grade GPU card. But then to train this commercial model, it would take a lot of resources. And actually training the model for just one round, let's say I feed 1.4 trillion tokens into the pre-training and also the fine tuning, then actually it costs about 2 million to up to 12 million US dollars to train just one model. So if you see if the model was trained, there are some errors in the training process, then you have to restart, then it actually costs a lot of money. And for the inference cost, let's say, okay, the model was trained successfully and you try to host the model in your server, then it will take about 30,000 GPU cards, and actually the daily electricity would be around 50,000 US dollars. So how can you imagine that this is a so expensive game to play? And Microsoft, which has invested a lot of money, 10 billion US dollars for OpenAI to develop this technique, and the ChatGPT is actually integrated into the Bing search engine, as you can see. Also, ChatGPT was very famous. Actually, within only 1 month, actually, I think it's said here, it says 5 days, actually it already attracted 1 million users worldwide. So comparing to the other applications such as Instagram or Spotify, actually it would take much longer time to acquire the daily active users. So this is really amazing. And of course, why ChatGPT is so amazing is because the quality of the answer generation is very good. No matter sometimes it hallucinates, the fluency and also the semantic information inside the answers are actually very fluent. Sometimes I feel like the passages generated by ChatGPT is actually better than my essay. So if I'm asked to write an essay, then I may not be able to write such a good essay. So this is something that maybe many people want to have, perhaps most likely students and sometimes professors. Okay, I would like to design some exam questions. Maybe I will just formulate a very special prompt to generate some multiple choice answers for me. And also, as you can see, the ChatGPT can also be able to write survey articles, which basically takes in informations from your prompt. If your prompt is very specific about the content or the keywords or the topics to be about, then the ChatGPT will be able to generate the essay very fluently. And also, ChatGPT can be able to write source code. So I asked the ChatGPT to write a web scraper, actually in Python, and actually it generates the source codes. Although some of perhaps this source code may not be run correctly, but I look at the constructs there and also the functions that was required to call the web scraping. Actually, it was pretty correct. So Yeah, that was about the capabilities of the ChatGPT. I believe that most of the students and audience in the room have tried using the ChatGPT maybe daily or maybe once a while. But actually, what's the methodology? What's the technology behind ChatGPT? So I mentioned pre-training a large language model, but what is a language model, by the way? So actually, language model is just an ability to predict the next word. So let's say I have a prompt here, which is called NYU Shanghai is located at, and then there is a blank here. So I would like the model to predict what is the next word token here. So maybe I will say, okay, if I will take a guess that I will guess that, okay, NYU Shanghai is located at Shanghai maybe. And then I will say, or maybe it's the more specific, it will be predict as at Pudong, or maybe at the name of the road and so on. So this is basically what the language modeling is about. Just create a machine that can predict what is the next word, given the prefix, given the context information here, or we given a prompt. So that you have and the language model basically how to predict the next word. So we just do the, enumerate all the possibilities. So, okay, we may consult the Oxford dictionaries, which have like most of the keywords, most of the vocabularies there. And then, okay, here is it. Here we go. We start from A to zebra to see all the possibilities. And then which one, maybe a few of them will be correct here. Maybe only a few of them can be used to fill in the blank. So the language model, what the language model does is not only just to look at all the possibilities, but also the language model needs to put a score on each of the possible candidates. So perhaps Pudong has a higher score, which is 0.8 compared to the other possibilities. Maybe Beijing may also receive 0.1, but Beijing is actually the score is smaller than Pudong. So if the language model try to choose what is the next possible word, given NYU Shanghai is located at, then it's most likely that the model will choose Pudong. So that's what the language modeling is about. So if we talk about the pre-training now, so actually, as I mentioned, it will just take in a lot of data like Wikipedia, articles, books, textbooks, newspapers, and blogs, and so on. Absorb all these language model data into the model parameters, into the 175 billion parameters. The contents are memorized and somehow generalized inside the model. And the nice thing here is that no human labeling is required. If you talk about machine learning, we always talk about, okay, I have the input data, and then I need a human to label the data for me. Like, okay, what is the class of the input? But for language model pre-training, there's no human labeling required. So which means that this process can be automated as long as you have computation. So now let's assume that you have a GPT-4 model pre-training on these 1.4 trillion of data. Then, okay, now let's start to generate some sentences from the model. So first thing to do is, okay, I don't know what to generate. Then, okay, I'll start with a prompt, which is just a begin of a sentence symbol here, S here. Then, okay, I'll consult the language model to look at all the possibilities. And now, okay, once, okay, randomly it will say that once will be the most likely word followed by the begin of a sentence. And then now the language model with one more token, which is the once, what is the next token to follow? Then it just try to ask itself to predict what is the next token, given that I already saw once. Okay, the model will generate another token. It says, oh, it's upon. Then the model will know that, okay, I know what once upon. Maybe, okay, now we can guess what is next. Maybe the next word will be a once upon a. Maybe the next token will be upon a time and comma, and then keep predicting what is the next token, and so on and so forth. That's the mechanism of the ChatGPT model. So basically, you give a prompt and as an input, and the ChatGPT will try to predict what is the most likely next word to be chosen. And then the ChatGPT randomly chose the one that has a higher probability, and then we feed this chosen word in as the new input to the ChatGPT again, and it tries to generate the next word. So what was actually learned from pre-training? So as you can see here, pretraining is like finding the relationships within the context. So for example, as you can see here, Stanford University is located in something here, and then California. So let's say if I ask a human or ask ChatGPT to predict what is the blank here, what is the word, most likely word here. So which means that the ChatGPT needs to be able to comprehend this sentence, saying that, okay, location is maybe something that is related to the blank. California is a constraint that is related to the blank as well, because these tokens are very close to the blank in terms of the word position. And also, it's talking about Stanford University. It's not talking about other universities. It's talking about the Stanford University. And assume that the pre-training process already has read the Wikipedia article about Stanford University. So therefore, now if we consult ChatGPT to fill in the blank, then okay, most likely the ChatGPT will try to output an answer, which is Palo Alto, a city name in California. And instead of Shanghai, Shanghai should receive a much lower score than Palo Alto. So that is what the pre-training has been learning. So actually, it's not just like doing this kind of task, but also be able to do the syntactical filling of the word and also co-reference and so on. So I will just put all the answers here. So I put a fork down on the table. So the ChatGPT should not put a word. I put and fork down on the table because this is a syntactic error. And now for this, the third example, the woman walked across the street checking for traffic over her shoulder, not his shoulder, or not the other possible tokens. Her shoulder is the correct word because woman is the information, is the cue that the ChatGPT will look at through the so-called attention mechanism, and so on and so forth here. And interestingly, as you can see in the last example, a ChatGPT can also be able to do some very simple arithmetics. So if I say I was thinking about the sequence that goes from 1, 1, 2, 3, 5, and so on, and try to predict what is the next token here. So actually, it's a Fibonacci sequence. It's just the sum of the previous two numbers here. But how come the ChatGPT is able to do the arithmetic summation to get the 34 as an answer? So we'll talk a little bit later in the presentation today. So okay, what is the basic technique or technology or modeling architecture that drives the ChatGPT for success? Actually, there's a building block called transformer. Transformer is, as you can see, is a box like on the right hand side. This is, you can treat this just a black box, but I don't expect that everyone will be able to read this. But what's inside is that there are two mechanisms that is very important to lead to the success of this transformer architecture. The first one is called the word embedding. So from humans, when we read the sentence or a text, actually these are in terms of symbolic form. It's just a symbol, just a letter, right? A, B, C, D is just a letter. But for machines, for ChatGPT, it requires to convert these symbols into a bunch of numbers, and this bunch of numbers is used to describe the discrete symbol. And also the second mechanism is called the attention mechanism. It's about which word token in a sentence should the ChatGPT be focusing on. So this is the self-attention mechanism in this transformer block. And how many transformer blocks are deployed in ChatGPT? Actually, there are 96 blocks which are stacked on top of each other in order to predict just one token from the input. So let's talk about word embedding in the ChatGPT. So as I said, so each word in the Oxford dictionaries, like teams and also leagues, actually they are all represented as a vector. So the dimensionality of this vector is over 10,000, as 10,000 numbers. As you can imagine, this vector contains 12,288 numbers inside. So, and each of the dimension has just a number to describe some characteristics of the word token. Like for example, teams here, maybe there's a dimensionality called sport. Leagues may also has a same dimensionality as the sport, and the numbers just represent that the relation, the strength or the weight about the dimension, each of the components. So why the symbolic word needs to be projected into the so-called the word embedding space. So what's the good thing about it? So if you look at the right-hand side here, so if I look at the word teams here, so actually I can use the vector algebra to locate what are the close words from the word teams. So as you can see that team, leagues, sports, championship, and also the soccer, these are the word tokens that are close to the teams. So we can use this so-called the dot product, we call it the distance or the angle between the vectors. So if the vectors are similar, let's say the teams and the leagues, the numbers inside the components of the vectors, these two vectors share the similarity. As you can see, 0.11 is very close to 0.1. Minus 0.2 is also close to minus 0.21. Then we can deduce that these two tokens are very close in the vector space. So that's the mechanism that is used as treated as the input to these transformer blocks to do the inference or induction. So the second mechanism that I would like to talk about is called the attention mechanism. So as you can see, this is a sentence: I swam across the river to get to the other bank. So bank can actually means a lot of different things. Bank can mean A, financial institution, B, sloping raised land. So in this context, so ChatGPT basically look at the whole context to decide what is the real meaning of the word bank. So, but how can the ChatGPT be able to read which words should be more important to characterize the meaning of a bank? So actually, we know for us, we know that actually B is the option. Bank is actually referred to the river bank, but through the attention mechanism in the transformer block, actually some of the tokens inside the sentence will be highlighted with a more focus. So swarm and the river will basically set the context to so that the word bank at the back here will most likely refer to the river bank instead of financial institution. So this is so-called the attention mechanism. So word embedding and attention mechanisms are the two crucial ingredients for the success of the transformer. So now let's talk about language generation inside the ChatGPT. So first we start with nothing. Also assuming we do not know what is our prompt, we just start with a begin of a sentence symbol. We feed this sentence symbol into this transformer block. Then it feed into another transformer block. The output produced by the first transformer block will be fed as the input to the second transformer block. And you just repeat this process many times, actually 96 times, so that at the end, you will get a probability distribution of all the possible word candidates in the Oxford Dictionary. And some of them has a higher probability score. Then you just choose the one that has the highest score. Maybe you just choose randomly according to the distribution here. So you will get the ones. And now you have one more token coming in. So ChatGPT knows that I should look at ones and then feed this prefix into the transformer block again and just repeat the same process. And then guess what is the next result? Then maybe upon the word upon has a higher probability, then the ChatGPT will choose this word to be appended in as the new input for the next word token generation. So that's how ChatGPT generates a sentence starting from a begin of a symbol. But regarding the sum of the skill sets, so okay, we fed these Wikipedia data, newswire articles. But perhaps this data may not be enough for ChatGPT to have some to equip with these broad skill sets, such as like simple arithmetics, or sometimes I want the ChatGPT to do some machine translation. Like in this case, what happens in a pre-training step here is that okay, let's create this kind of train data here. Okay, we feed the 5 plus 8 equals to 13. These are just tokens. This can be considered as natural language. I mean, this is not really English, but it's just a symbolic sequence of tokens. I'll just treat this as just like a quote unquote sentence and feed this into the ChatGPT to pre-train the model as the first step. Of course, I can also present other tasks such as like translation tasks, such as I'll look at the bilingual dictionary. This one is the translation task from English to French. Okay, I'll just have the thanks with a special symbol implies, and this is the maxi here. And then I also can put other kinds of tasks such as, okay, the word scrambling task. Okay, these words has some scrambling errors, and then I'll ask just like grammatical correction task. Okay, I'll ask ChatGPT to correct the word tokens for us. So I'll actually feed these kinds of data into the pre-training steps together with these Wikipedia articles. So that we would like to have the ChatGPT to be equipped with this so-called the broad basic skill sets. And not just this, ChatGPT also is able to learn from the input context. So what happens here is the ChatGPT may not be able to acquire all the data from us, like from students, from professors, and also from other users. They may have their own very special needs because of the new task. The new task may be like, okay, write the Java program, or a new task may be like write a Go program, and maybe ChatGPT may have some background information, but they do not know what exactly that we want to achieve. But from the user, what was the request from the user? But the ChatGPT has given the capability to do this so-called the learn from the input context. This is so-called the input, the in-context learning. So what happens is, okay, if you are able to write down your task description, just like what Olivier did in the demo before. So okay, maybe the task that I want to do is translate English to French. So this is the task description, also represented as a natural language sentence. And then you put in some examples, maybe just a few examples. Maybe in this case, we'll just put in 3 examples. Okay, sea otter should map to this guy. Peppermint should map to this guy. Plush blah 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 should map to this guy. And now all of a sudden I present a new prompt here. Cheese should map to what? Cheese should map to what? Then what happens is, okay, I'll just feed in the whole thing here into the transformer prompt into ChatGPT, and ask ChatGPT to pick what is the next word token. Just predict the word token one by one, and then you'll get the answer. And we want the ChatGPT to output the word fromage. Okay, I hope I pronounced this correctly in French. Anyway, so the prompt matters if you have created a worse prompt. So let's say, okay, my English is not very good, and okay, I wrote some prompt that may not be comprehended by ChatGPT. Then the ChatGPT may not be produce a reasonable answer for you. So this is so-called a prompt engineering. So there's a example here. So let's say I want to know what's the profession of Obama. So there's a very formal way of like asking this question. So like what did Obama do, for example? So Obama is a blank here by profession. Okay, maybe I'll ask the language model, ChatGPT, to fill in the blank here. So given the context, I'll ask the model to predict. Versus if I say in this way, Obama worked as a blank here. So actually, the second prompt will be more preferred than the first one, because the second one is more like the instructions that the ChatGPT likes to listen to, rather than the first instruction. So the quality of prompt matters for ChatGPT to generate the answers more accurately. And in fact, ChatGPT can accept different prompts. What is an MRI? Or you can explain to my 5-year-old son what an MRI is. And also, you can also pretend that, okay, I'm a university professor, and I would like to explain what is MRI to some medical student freshmen. So actually, ChatGPT, if you have different prompts, it will basically produce different kinds of answers according to the specification of your prompt. So here are some prompt templates used in the OpenAI ChatGPT. For example, like brainstorming, list 5 ideas of how to blah, blah, blah. and also do some classification tasks. Also, one of the commercial application would be like write a creative advertisement for the foreign product to be run on Facebook, aimed for parents. And then you put your product name, maybe it's just chairs, some kind of chairs for their babies and so on. And then ask the ChatGPT, just feed the whole thing here, and then you ask ChatGPT to generate the answer for you. And there are many tasks that ChatGPT can do. They can also chit chat. You can imagine that ChatGPT can pretend as an enlightened Buddha, and also to answer some like philosophical questions. And ChatGPT can also be able to answer some multiple choice questions and so on. And ChatGPT is able to adapt to the new task using the prompt engineering. So as you can see in this figure, so the x-axis is about the number of examples that you put into the prompt. Like, okay, where you do the word translation, you put some examples of the word translation pairs. And at the y-axis is the accuracy. So zero shot means that, okay, if you do not put any data, if you do not put any samples of data to ChatGPT, and if you do not put any prompt, then the performance will be like this, like on the dashed line here for the large model here. But if you are able to write a good prompt, just one sentence, without any, with one example here, then all of a sudden, the accuracy jumps from less than 10% up to more than 45%. But as more samples of the context is put in, then the performance is going up. This is the way of illustrating that the task adaptation ability for ChatGPT. So as you can see that if you only change the ChatGPT with 1.3 billion parameters, it's like nothing will happen. It's like, okay, it's going to nowhere. But when you try to increase the number of parameters from 1 billion to 10 billion and then up to like 175 billion, then you can see there's a jump. So that's why the trend here is that, okay, just make the model much larger to hope that the accuracy will go up further. So now let's see how ChatGPT can follow instructions. So let's say if this is the GPT-3 model, this is the model before ChatGPT. This is just a pre-trained model trained on Wikipedia data, for example. Then now I specify a prompt saying that what is the purpose of the list C in the code below? It's like an exam question for student. And then I'll show the code in the Python and just feed this text into ChatGPT, into GPT-3, and then unfortunately, GPT-3 model is just generating some options A, B, C, D. So it looks like these options, like the options generated by a professor, which tries to define the exam question. But this is not the answer that we want. We want the ChatGPT model to be more clever to follow the instruction, which was what is the purpose of the list C in the code below. Just focus on what is the purpose of the C here. So that the answer was not very satisfying. Therefore, if we feed this the same input to ChatGPT, this is the model after the so-called the fine-tuning process, which will be able to follow the instruction from human, then the answer will look much more pleasant. The list C in this code is used to store the values of the binomial coefficients, blah blah blah. So that answer is correct. But how to make the convert GPT-3 model into ChatGPT, which is able to follow the instructions from the human, from the input. So that comes the methodology here, which is the 3 steps procedure. We call it 3 steps procedure, how to convert a GPT-3 model into more intelligent ChatGPT-3 model that we are using right now. So the first step is imitate from human demonstrations. So what does that mean? So let's say I have many prompts collected from the users all over the world. So these are basically the users that try the GPT-3 API, application program interface. Just try on the web browser, for example, submit many queries. These are the task descriptions, and then ask the human labeler. Ask the human. As you can see, the the AI thing, artificial intelligence behind the scene, there are many human beings to label the data, to generate, to write the desirable answers to the prompt here. So let's say explain the moon landing to a 6-year-old, blah blah blah, and then there's a human which writes the answer. Some people went to the moon, blah blah blah. So this is a human created answer. And now you have, assuming you have many of these answer pair, prompt and the human quality answers pairs, and then we feed this data set into a GPT-3 model, trying to imitate how the human will write the answer, given the prompts that we saw. So this is called an imitation learning. Just learn how the human write the answers. But at this point, ChatGPT was not like trying to generate the answer by itself. It's like the self-driving car. What the self-driving car tries to learn is, okay, the computer sits inside the car, and we have the human to drive the car, right? And the machine tries to observe, just to observe how the human will, given a scene on the front, how to turn the wheel. So this is what the ChatGPT is also doing, the same thing, try to observe what the human is doing without doing any generation so far. So that's the first step. Second step is train a grader, train a virtual professor. So as example, let's say this is a question, this is a prompt, explain the moon landing to a 6-year-old. Let's assume that there are different outputs generated by ChatGPT. There are A, B, C, D. Some of the outputs will be better. So the first output will be A, explain gravity, blah blah blah. It seems to be not following the instructions. Answer B, explain blah blah blah. It seems also not following the instruction well. Answer C, moon is natural satellite of blah blah blah. Seems to be okay, but maybe not exact, because the satellite maybe not be understood by a 6-year-old kid. So how about the answer on the D here? People went to the moon. Seems to be like the format that the 6-year-old kid will understand. So therefore, we ask the human labeler. So there's another labeling process. We've asked the model to generate different answers, including the answer from the human. Then ask the human labeler to label which answer is better. So answer D will be better than answer C, and answer C is also better than answer A, and answer A and B are maybe just equally bad. So we have the human to label the data for us. Then we try to train the so-called reward model. So reward model can be considered as a virtual professor trying to grade the score of the homework assignment from the student. So the student is actually from ChatGPT. ChatGPT is the one to generate the answers for the homework assignment. Then we want to create a virtual professor to grade the homework assignment. And how to grade it? Okay, create another ChatGPT grader. We call it the ChatGPT grader, which is also another deep neural network, maybe like a transformer networks we saw before, with a similar amount of parameters, and trying to rank the answers. So B is better than C and better than A equals to B. So how to do so? So we have the ChatGPT grader on the left and also on the right, and feed a pair of prompt and answers. The first one is explain the moon landing to a 6-year-old kid. The answer is explain gravity. So that's the answer A. And this one is the answer D. And then we fed this prompt plus generate answers into the ChatGPT grader model. So this model is different from ChatGPT. It's a grader, it's a virtual professor, trying to output some score, here. So maybe at the first place, the ChatGPT will make some mistake. Okay, the score is 8. However, the score from the good answer is only 4. But the learning objective for the grader is that we should make this answer to have a higher score. Maybe it's a 10. Score of the 10, maybe this score is just like a score of maybe a 3 here. So we need to adjust the answers. So that's what the ChatGPT grader is doing. So trying to grade the answers from the machines. Now let's go to the third step. Now just like an analogy. Now we will let the ChatGPT to go on the driving. Just like I'll let the ChatGPT to generate the answers given the new prompt from a data set here. So as you can see, there's a prompt data set, and we sample one of the prompt from the data set, write a story about frogs. Then I feed this prompt into the ChatGPT model, trying to generate some answers, maybe once upon a time, blah, blah, blah. And then I'll consult a ChatGPT grader, which is called the reward model, to score what is the score for this answer just generated by the machine, by the ChatGPT. So if the reward is good, so let's say check part of the ChatGPT grader, and ChatGPT will just vote for a score. Okay, 8.5 out of 10 seems to be very good. Then okay, this reward score will be feedback. There's a feedback loop to the ChatGPT model, trying to tell the ChatGPT model that okay, you are doing a reasonably good job. But of course, if your ChatGPT will make a mistake, so it generates some very bad answer, then the reward model, the grader, will be able to output a very bad score, maybe like 3 or 2. Then the ChatGPT, this score will be fed back to the ChatGPT model, and the ChatGPT model will be able to adjust the decision, adjust the we call it the policy or the strategy, that the next time ChatGPT should not generate such an answer because the answer score is too low. So that's the first step. So learn from the feedback, learn from the human feedback, and also the feedback model, the grader, is also virtual. So there are these guys are just bots, just like bots to do the task for us. So there is also hallucination problem in the ChatGPT. So as you saw from the demo from Olivier, so actually if I say, okay, how can I contact myself, him, then actually it generates a wrong email address. And I think the hallucination problem sometimes would be not a bad thing, because hallucination for creativity is required for like art, or for like writing some creative essays or writing poems, then a hallucination is a good thing. But if it's for actual generation, fact generation, then this is problematic. And also the knowledge limitation in ChatGPT. Actually, the ChatGPT needs to keep update with the recent knowledge from the web, also from the news. So from Wikipedia. So how can the ChatGPT be able to update itself? It's also a very big problem. In summary, ChatGPT is a very powerful conversational chatbot. I do believe that the launch of ChatGPT has affected a lot of people. I think in a positive manner, and I think the success for ChatGPT is due to more data, parameters, and computation, and good prompts, and also the learning from the human preferences. And in the future, it was forecast that the new version of ChatGPT will be 100 times bigger than the current version, which will be expected to be much more intelligent. Thank you so much.
Okay, thank you. That was super helpful. We only have time for a couple questions. So is there anyone in the room that wants to? I have questions, but yeah.
Hello, Professor Tam. So I know there is a very popular opinion in the academia that there is not much technical novelty for ChatGPT because imitation learning, critic actor, these are not very new ideas. So my question is, what's your opinion about this opinion? And what do you think about the divergence between academia and industry about this kind of application?
Yeah, thanks for a wonderful question. Yeah, I think that from the academic point of view, yeah, these techniques are not new. I mean, the reinforcement learning from human feedback, this kind of pre-training, and also transform architecture was also invented by Google in 2017. So this thing is not actually new. I think the success of the ChatGPT is all about the engineering capability of the company, so they can be able to have like the resources such as the GPUs. They have the resources to clean the data, to scrape the web, the whole web, Wikipedia's, newspaper articles, and be able to train the model in a limited amount of time. So that's not easy to do. I mean for us actually we cannot do like in a university. So I do believe that there is a divergence between academia and the industry. So what will the winning story in the future? So some people will forecast that the companies who has the most resources, computational resources, or also talents will win the AI war here. I may not say the AI war, maybe just these companies will win. Although their technology may not be the most advanced, still the big thing is the success of the recipe is the increase in model size, increase in the model the data, and also increase in computation, and also increase in the amount of money spent. So so these guys has most resources. Yeah.
Okay.
Professor Wilson, I'm kind of curious about how you calibrate the reward model in step 3.
Right. So so that's probably a very technical question. So so as you can see from the slide here, so you see we asked the ChatGPT to generate some answers, and the reward model tries to rank the answers. So try to rank the answers. So of course, some of the scores returned by the grader, by the virtual grader, needs to be normalized, needs to be calibrated. Maybe some answers are just average answers, so that you want to calculate the so-called advantage function, the advantage of the answer that is better than mediocre. So maybe the mediocre answer may still receive the score of 4 or 5 out of 10. So we have to do some calibration, by subtracting the reward score mark by the score predicted by the critic model, basically.
Okay.
Can I ask, what is the technical lower limit? For example, if Elon has a baby and he makes everything that they read or movies that they watch, everything that they say, everything is recorded and fed into that model, not the whole internet. So could you create a ChatGPT that is personalized and would imitate you as a person? Let's say, for example, after that person dies, you would ask that person a question and they would have been fed only data either read or generated by a specific human being over the lifespan of 100 years.
Yeah, so I think that's a very interesting application. I mean, if the model is able to comprehend the data well, so which is you basically continually feed these utterances into the model. It's stored inside, maybe it's stored out as external memory. Maybe the model at some point is able to really read the external resources, like the data from the person. Then I would think that this is possible. I think that this is possible.
Okay, last question.
Thank you very much for your presentation. I have a little bit of an outsider question. I'm curious, with ChatGPT, did we learn anything else kind of like about, I don't know, how the mind works, how language works, how learning works? Or did it kind of like suggest or maybe also rule out different approaches about artificial intelligence? I believe at some point there was some idea about embodiment is very important. There was some ideas about like ontologies are very important. Did we sort of like from kind of if we look at what is happening right now, did we learn anything new?
Yeah, so I do believe that ChatGPT has some kind of capability to do some induction, like the ontology, like maybe apple is a kind of a fruit. So if you imagine that this kind of ontology is also described as natural language. So apple is a kind of fruit, and so on. You use this to sentences to describe this common sense knowledge and feed this everything into the model to just try to to learn from the data to try to do the prediction. I believe that the model somehow learn from this large amount of parameters. So the trick is you feed the data. The data we feed the model will learn the knowledge that is intended to learn. Yeah. So it really depends on how we feed the data into the model.
Thank you so much. This is obviously the beginning of this conversation. It's not going to end now, and we're so honored and grateful that you can be part of this conversation with us.
Yeah, I want to add my thanks. Those who are online, I apologize. We don't have time for the Q&A. We have your questions. Maybe later on we can have another conference of the same type with another speaker. And we'll make sure to add your questions at the front of the queue. Thank you very much, everyone. And thank you in particular, Wilson.
Thank you, Olivier and Anna, for hosting. Thank you so much.